So welcome back. So in the previous session, we have seen how to create NumPy arrays, how to do the basic math and operations in NumPy arrays. In this session, we'll continue with NumPy and we'll also extend the session to Pandas. So what is still pending? So we'll also get a step deeper into NumPy array to see the change, how to change the shape of an array, how to perform operations across rows and columns, we'll understand the broadcasting and the concept that makes NumPy both fast and flexible. So let's see how to reshape arrays. Let's import NumPy as np. A is equal to np.array, and I'm going to pass in some numbers 1 2 3 4 5 6. B is equal to, right, I'm going to say a dot reshape 2 3, right? So reshape a dot reshape 2 3. So I want it in 2 rows and 3 columns, matrix of 2 by 3, right? So that's what this is. So let's print. So the original was this, and let's print reshaped into 2 by 3, right? So this is what this is, slash n is b. Alright, so comma b, right? So you can see here that this is how the original the NumPy array was 1 2 3 4 5 6 and reshaped, right? So reshaped into 2 by 3 is 1 2 3 and 4 5 6, right? So that's the power of that dot reshape. So reshape changes the shape without changing the data. This is very much essential when we are working with NumPy, right? So, and we'll also see the broadcasting basics, how to do the broadcasting basics. So what's broadcasting? Let's say a is equal to NumPy array 1 2 3. Alright, so and then I'm going to give it as 4 5 6, and I'll say b is equal to NumPy dot array 10 20 and 30. Now let's print a plus b, right? So a plus b, right? So how it was in different shapes, still we are able to add these two NumPy arrays. So broadcasting allows operations on arrays of different shapes without writing any loops. So NumPy broadcasts b to match the shape of a. That's what it's present here, right? So these are two more additional concepts which I thought very much essential. Now let's step in to Pandas. So what is Pandas and why is it the most essential library for data sciences and data analytics? So Pandas, so Python's most powerful data analysis library is what Pandas is. So while NumPy is great for numbers and arrays, Pandas help you work with tables, rows and columns, just like Excel or SQL. So by the end of the session, you'll be able to create and understand series and data frame. These are the two important data structures in Pandas library. How to read and write an CSV file, how to access and modify rows and columns. So what is Pandas? Like we have seen, Pandas is a library for handling structured data like spreadsheets, tables and CSV files. So how will I use it? Import Pandas as PD. Okay, so just ignore the warning. Now what is series? Series is nothing but an one-dimensional data. Series is an one-dimensional data. Say for example, I'm going to create S1 is equal to pandas.series 85 90 78 92, right? So and then I'll have an index is equal to Arav, Meera, right? So Divya, and then let's say Ravi, and I'll print yes, this one, right? So this is what you call it as a series. This has an index and this has a value. This is a one-dimensional array. So these are the actual values and this has an index to it. This is what you call it as an Pandas series. In other words, you can call or you can compare it like a column in an Excel or a single list of values within labels that has an index. So Pandas series is a one-dimensional labeled array. One-dimensional labeled array is called as a series, right? So that's what you can see here, right? So if you say I don't want to give an index, what happens then? Let's given data is equal to, I'm going to give 10, 20, 30 and 40, and I'll say pandas dot series data, right? So 10, 20, 30 and 40, and it has an index value to it, right? So and the left column is the index. This automatically has 0, 1, 2 and 3. So the right column is the values here, right? So this has this values. And let's understand the other data type, the data frame. So what is a data frame in Pandas? A data frame, a Pandas data frame is a two-dimensional table. Like an Excel sheet or an SQL table, it consists of rows and columns. So what does it mean? Let's give an example. Data is equal to, now I'm going to have a first column as names, and there are multiple names here. Arav, Divya, Meera, and there are multiple, many marks here. Marks for each and every names that I'm giving. 85, 92 and 78. Let's give the same. So this is a dictionary which has name and marks as the key. And what's the problem? This is supposed to be here. Right. Now I'll make it as a data frame using pandas pd dot data frame. Pd dot data frame data. Pd dot data frame data. So df is equal to pd dot data frame and data. Print df. Right. So you are able to see the name and marks. Right. So this is the data that we have. That's the data frame that we have created here. Name and marks. So the first column is the index, right? So each and every other columns is in series. So name is in, if I'm going to extract name alone from this data frame, this becomes in series. Combination of multiple series is an data frame, right? This has an index and this has various different columns. You can also add a custom index. How will I add a custom index? In pandas dot data frame. So whatever the data that I have passed data, and I want to create it as an index is equal to, I'll call it as S1, S2 and S3, right? So df is equal to is this. Now let's print df, right? So S1, S2 and S3 is the index, and I have the different names Arav, Divya and Meera, and I have the different marks. Now how will I access a data frame, right? So if I want name alone to be extracted, name column, I'll use this data frame df square bracket. I'll use the square bracket and give the name of the column, right? I'll give the name of the column name, right? So, and if I want to make use of or extract two columns, I cannot use name comma marks, right? So this will throw an error, right? So this will throw in key error. It does not understand names and marks. I should pass multiple column names in a list. If I'm going to pass it in a list format, I'll get the output, right? So if I'm going to pass multiple things, I'm going to pass it in a list and I'll get the output. So how will I compare a series versus data frame? Series versus a data frame, key differences. So I have feature, series and data frame. So the dimensions are one dimensional here, and data frame are two dimensions here, and data type is like a single column. Here the data frame, it has like a full table, right? So the data type has multiple things. So access patterns, right? So if it's a string, use in single or double quotes, or if it's a number, they just use that integer directly. For data frame, I can use the column name and lock and ilock. So index based filtering, we can do all those things. Right, so if I want to take a single variable or a column, I'll use series and full data set with multiple values. I'll call it as a data frame. So to put it in simple terms, series is nothing but a single column in an Excel sheet. Data frame is nothing but an entire Excel sheet with multiple columns and rows. That's the simple real world analogy everyone can understand, right? So pd dot series, pd dot series, pd dot data frame dot loc dot ILOC. So these are the important things that you need to remember. Dot LOC is nothing but access by index label. Dot ILOC is nothing but access by numeric index, right? So this is what we have learned from Pandas series. From Pandas, the series and the data frame. So we are covering the basic aspects which are required for Python for data science. Thank you.